The second thing that I want to talk about would be the what we consider to be the fuel of life, and I will be talking about this a little bit today. But we're as your book mentions, this is a chemical entity known as adenosine triphosphate. Now you're gonna have to bear with me for a moment because I'm still in a wheelchair from my accident, and I'm going to try to draw here on the board. This will just take me a minute. I'm going to try to represent to you the structure of this chemical compound. So let me just show you this in pieces. We call this first thing that I've drawn here, this is known as a pyrimidine, and actually of the 4 nitrogenous bases that comprise DNA, pyrimidine is one of them, or at least that type of structure. It's not the entire pyrimidine molecule, but that's part of it. We also have these kinds of things, which are called purines. And I'm actually going to erase this. I should actually show you this as a series of alternating single and double bonds. So each one of these double lines here represents a double pair of electrons, for those of you that haven't had much chemistry. What I don't show, where I don't actually show an atom at the apices here, these are carbon atoms. Carbon always has 4 bonds to it, so if you count and you only see 1, 2, 3 bonds, then that implies that the carbon also has a hydrogen on it. So there's a CH here, a CH here. These are just carbon atoms, and there's a CH over here. Nitrogen always has 3 bonds. I'm going to extend a bond down here from my, oh, and I have to put another group up here, which is an amino group, and this makes this the purine that's known as adenine. Okay, so now I'm going to further extend this, and we're going to put in a sugar, which is this compound here, and this is called ribose, and then attached to that another CH2 with an oxygen, and then there's going to be 3 phosphate groups. Whoops. It's a little hard for me to write on this board because it's actually holding it up. It's not a freestanding board. It's just a freestanding board. So I apologize if my handwriting isn't very good. Let me see if I can move my camera over so you can see everything that I put down here. But you'll notice that there are 3 phosphate groups here. What I want to call to your attention is that if we cleave off this 3rd phosphate group, these groups here are basically these are very high energy bonds. So if I actually cleave this off, I go from a compound called ATP, adenosine triphosphate, to adenosine diphosphate. And what we're going to find out in this chapter a little bit, and I will be talking about this just very, very briefly, is the idea that there are processes whereby the cell is going to store energy. So there's some chemical reactions that are going to give off energy, and when these reactions occur, the cell is going to actually take a phosphate group and take an ADP molecule, that's one that only has 2 phosphates, and store that extra energy by building up the bond to make ATP. There's going to be other reactions that are going to actually require energy, so in that case what we're going to have to do is we're going to have to lose a phosphate group and get the energy out of the stored energy in the ATP molecule. So ATP, adenosine triphosphate, is an important molecule for these considerations. Okay, so that's one of the other things that's going to be stressed in your book.